Alrighty. Electron is in the plane of the page and a magnetic field out of the page. So let's draw the magnetic field out of the page. I always like to draw it. It always makes me feel better. And then here's this electron. It's a negative charge, right? It's going to the right. I peeked at the next problem, and I know that the next problem asks me about it going to the right. So I read problem 5, and I draw it going the direction that it says in problem 5, right? Now, if I do my index finger in this direction, and then my magnetic field is my middle finger, all right? I'm pointing to the right. I've got my middle finger out of this page. My thumb is pointed down the page, but it's negative down the page, so it's up. Right? So the force is negative down the page because it's an electron, right? Don't mess that up. That's what everybody messes up. Don't be the one that messes that up. All right. So, but if you make that mistake, then draw the magnetic field the other way. If you always make an even number of mistakes, you're good. Okay. Now a force to the left makes things turn counterclockwise, right, or anti-clockwise. So this thing is definitely going to go anti-clockwise. Okay. All right. So let's see. Now let's figure out the radius of its path. So here we say that QVB is equal to mv squared over r. Now this is actually in your data packet. If you look around, you'll find that in there, the mv squared over r. And now we're all set. We want to find the radius. I'm going to cancel a v, and I'm going to get r is mv over qb. So let's just plug numbers in here. Our mass is an electron's mass, so look that up in the data packet. It's 9.11 times 10 to the minus 31st kilograms, and then the velocity is 2.47, and then the charge is 1.602, and the magnetic field is 0.128. All right, so we spring to action. 9.11 E negative 31 times 2.47 E6 divided by parentheses 1.602 E negative 19 times 0.128, right parenthesis, 1.097 times 10 to the minus 4th meters. Well, that's awfully fine. 1.097 times 10 to the minus 4th meters. What does that mean? I think that's 0.11 millimeters. Wow, that thing's just whizzing around. It's got to have a really high frequency. That would radiate all kinds of crazy stuff. Right? I mean, think how fast it's going. It's going 2,470,000 meters per second, and it's going in a path that small. Okay, so let's see. 10 to the 4th. Oh, they have 10 to the 4th. Why do I have 10 to the minus 4th? Are they wrong? I hate to do this problem a third time. Yeah, that's got to be wrong. That answer is wrong. Let me just double check. 9.11. Let's go up here. I could have typed something in wrong. 10 to the minus 19. Yeah, I could have just typed that. Oh, there you go. Yeah, this should have a minus in front of it. Just a small factor of 100 million. Anyway, there you go.